Okay, are we ready to start?
Yes, sir. We'll be starting. Sahashish, are you there?
Yes, I am there, all filled with energy and really excited for your session, sir. So, just informing, sir, all the attendees are watching us live on the YouTube, and these are the people on Zoom are only the collaborators and the organizing team committees. So, quickly with that particular information, let's start with another exciting session. Good evening, everyone. Like once again, this is Tech along with its collaborators, Affinity Branding, IEEE, BMS, CE, SCDS, India, Checked, Code Chef, VIT Chennai, Microsoft Innovations Club, VIT Chennai, Music Club, VIT Chennai, Skillenza, Ojasvi LPU, the Dramatics Club, VIT Chennai, and Affinity in sponsorship with Verivo Motors and EduTech are thrilled to bring you these sessions and this particular international research consortium. Welcoming you back from a very relaxing yet energetic music concert, what we have just observed before this session. So now it's time to dive deeper into the ocean of knowledge and expertise. So let's welcome
Dr. Ebenezer Isaac, a graduate from IIT Madras with certificate of Python, data science, and AI development. Dr. Ebenezer, who started out as a lead data scientist at Ericsson R&D, is now the product manager. From solving challenges in the telecom industry by applying data sciences to playing the harmonica, Dr. Ebenezer has shown great talents. He's a forever learner and believes that self-analysis is the finest way to become the best version of yourself. Mr. Isaac, please take the floor.
Okay, thank you very much for the introduction, Yashavi and Sahash. Okay, I think I just start by sharing my screen. Let me know once you're able to see the presentation.
Yes, sir.
Yes.
Okay, so the title of this presentation would be a gentle introduction to AI industrialization. The reason why I want to keep it gentle is that when you start with AI industrialization, the actual AI element is close to or even less than 10% of the entire work that you do. So most of AI and machine learning goes into making or formulating the solution, but once you go ahead with deploying the solution, there's a whole lot of items that you have to take into account. And just so that you will not be overwhelmed with the sheer amount of detail, I would like to start with an overview so that at the end of this session, you would have some idea on your mind of what to keep in mind when you want to actually deploy an AI industrialized solution from end to end. So I'm Abi Isaac, an AI technical product manager and from Gaia division of Ericsson. And my job is to apply AI and machine learning to telecom domain and obtain meaningful insights. and use those insights for automation, optimization, or meaningful change. The objective of this session is, one, for you to understand use case flow, the flow of the AI use case from end to end, and what are all the stages that are involved. Then how would you gauge a model's performance, and what are the items that you need to keep in mind when you have to deploy it in the environment. So what are the requirements that stems from the environment, and the machine learning and data pipelines, security and reliability, and some issues and challenges for you to have to keep in mind when deploying the entire solution. So both technical and non-technical issues. So this is what happens when you're deploying the use case. The first step would be to identify the problem. And this itself is a phase that would take a month or even 2 months, depending on the complexity of the problem. So this is what we call the ideation phase. The members, they're trying to identify what are the gaps that you can solve an AI problem, and see whether AI can be solved with that particular problem. And the next step would be to generate the proof of concept. And this is also considered to be the innovation phase. Now, this phase, I'm sure everybody would be familiar with, because this is what we do in our projects, in our UG projects, or MS, or PhD research. What we technically do is generate the proof of concept. And this is why the output of this would be published in whatever medium. And this phase is where you try to do with the Jupyter notebook or any Python script, just to make sure that the expected input gives the expected output in a meaningful way. Now, the next phase, however, is when things get a little bit more complicated. First off is application. And this is the start. This is actually the start of the industrialization phase. Now, when you have the proof of concept, you would have to make sure you can deploy it in a customer solution. And since it's not exactly a product per se, you need to test the waters. That's why you would have to have a tie-up with the customer or any other area where you can test your application. You can say it's sort of like a beta testing, and try out whether the system works in a way it's supposed to work. Now, if the system already fails in the proof of concept stage, then you would have to change your idea. But if it fails in the first office application phase, it can create a bit more impact. You're gonna again go back to the proof of concept stage, change your proof of concepts, and come back to the first office application. And you would have to think of a lot of items. So the algorithm that you think that is going to work initially in the proof of concepts may not work in here. You have to make some changes, and you would have to do a lot of other items. So this is what we call the tech stack. Your solution would go somewhere in the tech stack, but you would have to make the other applications of the stack matter. And I guess I'll get to that stack when we talk about pipelines. But this is what it's all about. First office application is basically a test application or a prototype that you execute in a controlled environment, and to see if your concept works. And once you see that it works and it behaves with relatively minimal errors, you can go ahead with production. This is the deployment phase, where you provide all the details that is required to market a product, and give the lead to a maintenance team. Now, maintenance, this is where we have life cycle management. So this is a team who would handle the operations and pretty much the rest of the cycle. So once you see that your project is working and it can be handed over, if there's any other issues with the project, they would have a maintenance cycle where they can create issues and they can solve themselves. If there's something that cannot be solved, they raise that to another level. So in here we have, I think you would hear about 4 levels of issues. So level 1, 2, 3, 4. And if the 4th level would be the issue that we would take into consideration. So that'll go all the way back to the people who are doing the first office application. So the certain error that is application related, we'll fix that application and produce a patch so that it can be put back into production and testing and go to maintenance. Now, this is the entire flow of the use case. And now, before we go further, I'll have to ask you an age-old question. Which is the best machine learning model for a given problem? Well, the first thing that comes into mind would be to get the model that most correctly predicts what is what it expects to predict, right? What is expected to predict. Now that this would generally mean the ones with highest accuracy, precision, recall, F1 score, etc., or the R squared in terms of regression. Or you can even say the one with the lowest error, like mean absolute error, MAE, or root mean squared error, RMSE, right? Or is it? So I like to introduce you a thought-provoking quote. Knowledge is knowing the tomato is a fruit, and wisdom is knowing not to put it in a fruit salad. Now, what I mean to say is that a model with the prediction error would be the best when you go publishing research papers, because of course they all talk about reducing the delta X error, right? But it may not be suitable for all of your problems. So this is when the stuff you learned in your earlier years of undergrad come back to haunt your solution: data structure and algorithms. So what does it take to gauge a model's performance? So first is evaluation metrics, something that you'd be already aware of. This is where metrics like precision, recall, F1 score, or RMSE, MAE, R squared, all these things come into play, just to show that your machine learning model performs well. Then would be computational complexity, like in terms of both space and time. Let me give you an example. Deep learning is becoming more and more famous, or the go-to solution in recent research. So I guess there's a trend right now where if there is a research that is published in a regular machine learning model, apply a deep learning model to show that it does even better and publish that through. But imagine this: when you want to do an anomaly detection on an entire region of base stations. So your phone connects to a base station, and that connects to a home network. It does a processing, and if something wrong happens at the base station, your call will not get through. You would have a loss. You would have a degradation. So you would have to fix it. Now, imagining doing that anomaly detection and do a deep learning model in each of the base stations. So you would have, for a single region, over 2,000 to 3,000 cells. So a base station would have around, let's say, around 3 to 12 cells. And if you run a deep learning model on each of those cells, and each cell having a time series data they call KPIs, key performance indices, of over 300. So it can be 300 KPIs to a single cell, and consider 300 multiplied by 3,000 and deep learning model on all of them, your system will just blow up. Whether you use a single system, a monolithic system, or if you want to employ a deep learning system on each of these nodes, that means you would have to employ a GPU on each one of them, in addition to what they're already meant to do, because they already meant to do a certain task. That's why these machines are in place. They calculate it, and you'd want to employ a machine learning solution to solve a problem instead of creating a new one. And that's when items like deep learning would not do when you actually want your system to scale. And that's not all. We also have interpretability and explainability. Now, as models get more and more complex, the interpretability diminishes. The most interpretable model could be a simple rule-based model, or a decision tree that can be broken down to rules. So when you cannot break down your rule-based your model into rules, you would have to go ahead with explainability. Then you would have heard explainability model like Lime and SHAP, so that you would know which features that the model could be thinking to be more important for a given prediction. And a word of advice that I can like to give is that you can go ahead with a model with lesser explainability or interpretability when you can readily evaluate a solution. So if I'm looking at facial recognition software, or pose estimation, or an action recognition, or action detection, whatever, once the system gives out an output saying that this is an action, this is a theft action, or this is a face of a certain person, any human can readily look at that and verify it with ease. Now, assume when you talk about multivariate anomaly detection, I'm talking about 10 to 20 KPIs or time series data being fed into the system, and the system coming out saying this timestamp is anomalous. What does that mean? Why are we doing anomaly detection in the first place? We want to find out that something's wrong in the system so that you can correct it. If a system just says that these with this 10 variable combination, you get an anomaly. What can an operator do? What does it mean for an operator? You know something's gone wrong, but you do not know what went wrong. So this is when you'd have to sacrifice some of your accuracy or whatever it is, so that your model can be more interpretable, so that it'll make sense. So when you're designing machine learning systems, focus on what does it mean when a machine learning model provide a certain prediction, and how you can make use of that prediction in that business. So these are the things I like to call 3 dimensions of model performance. So people tend to think only 1 or 2 of them, but it is always important to think all 3 of them when you're producing a system in production. Then you would need, so once you have this machine learning model in your solution, you need to deploy it somewhere. So you need to have the environment in mind. So the first requirement would be the resource in terms of compute and storage. So compute resource, simply the number of cores the system has, and what is the capacity and the gigahertz that computation per second of flops, teraflops that a system can do. And the storage would be both the physical, that is the main memory storage in terms of RAM, and also the secondary storage, the disk space. And when you're deploying systems, you should try to make the systems horizontally scalable than vertically scalable. So what I mean by vertically scalable is when you have a single system, let's just say you have a single node with hundreds of cores, and let's say 500 GB RAM space, enough for you to run your application. Now, instead of you imposing such a solution, it'll be better to do 10 or 20 systems with just lesser number of lampshades. One thing, it is cheaper to have horizontally scalable systems. Second thing is that if any failure happens to any node, so if you have only a one node, if that one node fails, then your entire solution will come to a halt. But if you have a horizontally scalable system that is running on top of something like Kubernetes for a resource orchestration, and then these failures can be handled or mitigated gracefully. So your system may degrade in some aspect of performance, but the use case itself, the requirements would not be abruptly stopped. So one thing to keep in mind is try to make sure that your solution is horizontally scalable, and try not to make it vertically scalable. Then would be network connectivity. When you deploy your solution into a customer network, there are many implications in it. So one item would be the firewall and port openings. You would, when you're installing in your own laptop or in the company server, you know what are all the resources you have access to, so that you can do pip install a certain library, it'll be installed, and you can carry on with your rest of the installation process. Or even you can install a file that requires continuous pulling of data from a certain internet source. Like suppose if you want to install LaTeX distribution, and there's an online installer that will install multiple packages as on the fly. But when you go for a customer network, you would usually end up having firewalls, and you need to open the port on a case-by-case basis. So when you're installing a package, let's just say you're installing Kubernetes, you would need to know what are all the websites that package is going to access, and let them know beforehand that these are the packages that are going to be accessed by this particular application, and so that they can open the port for each of those packages. Otherwise, your system would, one thing, you cannot go past the installation phase, and the bigger problem would be the complete internet availability. So sometimes even the internet itself will not be available in certain regions. So you would have to follow a certain air-gapped method of installation. So air-gapped method is where you'd have to download all the files that you require for your installation, and in a certain location, and use that location as a proxy. So suppose if I want to install something like Kubernetes, and it has certain images that you'd have to download, images in the sense of Docker images that you'd have to download from different sources, you'd have to already download those images beforehand and create that area as a proxy within your customer network, so that you can access those proxy locations to continue with the rest of the installation. And these are the complications you'd have to keep in mind, and per customer, because it's not just one place. Certain customers would have different types of restrictions. So you have to understand the restriction for a certain customer base when you're deploying the solution. Then pipelines. Now this is a bit more interesting. The machine learning pipeline, most of which that many of you be already aware of, starting with pre-processing. So this is when the data that you have at hand has to be formatted in a way that can be understood by the machine learning algorithm. And this would include feature engineering or feature selection, then proceed with training. And everybody knows what machine learning training is. You just train and identify patterns on the pre-processed data. Then we proceed with inference. So once you have trained the data, you would be creating a model, and that model can be used to infer. So inference can be made based on that model. So when you have the new data also has to be pre-processed in the same way as it is being done by training. So you also have models coming from training, models coming from pre-processing and training. So we have pre-processing models to pre-process the new data, and you use the training model to find out run any sort of inference. It could be a prediction, it could be a regression, and or even be a simple clustering, any sort of inference using the trained model. Then you'd have to post-process the data so that it can be suitable for whatever application you're working with. So when you go for classification or binary classification, you get the usual answer as 0 or 1 or true or false. You would have to know what does that map into. So you want to find that something is a fruit or not, then it should be fruit or not fruit. This is just a simple example, but post-processing can be even more than that. Now, these are all processes, and these processes has to be orchestrated using a workflow orchestrator, because when you run these sort of processes in a notebook or a Jupyter notebook or in a simple script, we click on a function or a button to run these processes. But when you're running this live on a production engine, it has to be orchestrated so that you know that pre-processing starts every 15 minutes, and every day you'd have to do the training so that you can avoid concept drift. And every 15 minutes you also apply inferencing, then you bucket into 5 minutes. Then post-processing has to be done periodically as well. These are what we call as a workflow. So this is we have training workflows, inference workflows. It differs from application to application, and you can use packages like MLflow, Apache Airflow, or Augur workflow to do the same. And personally, we found that we had a lot of errors to deal when you worked with Apache Airflow, and Argo was better for our purpose. I mean, with my experience, but any of these can work equally well if you want to orchestrate a machine learning pipeline. Then all this pipeline needs to interact with data, or these stages of the ML pipeline. So data pipeline starts with data extraction. This is when the data from the customer source, or whatever source it is, it can even be IoT, so it can be multiple sources, is extracted and sent. And then after the data is extracted, it has to be ingested into the system for pre-processing, for actual processing. So processing is where everything that you see in the ML pipeline will come into play. So this would be a database where you store data from raw data to process data to post-process data, and even the models. So when you apply pre-processing, you get pre-processing models. So when you say PCA, principal component analysis, that's a pre-processing step, but you'll generate a model based on that, and that would be the principal component vectors. Then we also have training, and out of training you'd have models. So if you're doing other type of training such as forecasting, when you want to do something like anomaly detection, you'd have to remove seasonality. And to remove seasonality, you would include models like SDL or neural profit or Facebook profit. These are all forecasting models and seasonality decomposition models that you can use to remove seasonality from a certain data. And after extracting those elements, and all these things are generally models, and those models also have to be stored in a certain location. So the output of all of these items each provide a certain item that can be stored in the database. Then we go over the presentation layer where you actually show the output. So the presentation layer can be simple as sending the data into a customer database, or providing an application where you can readily view the data. And I can provide an example with the Elastic Stack. And Elastic is a company which does, which is pretty much famous for these sort of data pipeline stages. And an example could be starting with beats. So beats, you can have file beats and metric beats. These are lightweight agents that you can install on computers to extract data periodically. So when I want to take log data, like event log or system logs, these data can be taken from a remote system periodically and sent into another system. And the other system would be the system where Logstash is installed. Logstash is a component where you take in data from multiple sources, one or more sources, and format it in a way that can be used by the database. So you format the data, and then you can send from multiple sources and send it to another source. And the source that we're talking about here would be Elasticsearch. Elasticsearch, nothing too fancy. It's just a database. The Elasticsearch is a database that is well equipped to handle time series data. And this is where we store data in indices. So usually databases you heard of storing as records or tables. And in here, we store data as indices. And each index would can be considered to be a table for your case. Then Elasticsearch can be connected to a presentation component called Kibana. So Kibana is a dashboarding software that you can use to view dashboards that read data from Elastic indexes and present it in a way that will be useful for the user. So you can create any number of dashboards for your use case. This is a good overview of what is an ML pipeline, machine learning pipeline, and a data pipeline. Now, I can go on for 2 days and still not complete the overview of the most critical elements of security and privacy required for a marketable product in today's world. And the reason is because in our experiences, we found out that we spend more than 2 times the time it requires to develop a product for you to do the same time for the whole security, reliability, compliance. So suppose if it takes X amount of time for you to develop an entire end-to-end product, it'll take more than 2x time for you to get security and reliability compliance checks. So I'll just list a few key points in here so that it comes in the top of your mind. The first thing would be security by design. Now, when I say that security is about compliance, what some people do is that, what many people do is that after completing the entire product, marketers at times just try to find out what are the immediate things that you can do so you can check that off a list. It shouldn't really be that way. Security by design, you would have heard of in many companies like Apple or Microsoft, but what we mean is security should be considered in the end-to-end design of all phases in the software development lifecycle, SDLC. So that means you should think about security right when you're designing the first office application. So POC is when you're designing the proof of concept, you know that the system is going to work for a given requirement. But when you're designing the first office application, that is when you should already start thinking about security, not all the way in the deployment stage, the production and deployment stage. Then limit 3PP. 3PP stands for third-party packages. And the reason you want to limit it or minimize its use is because the more third-party component you have, I'm saying limited because we are in a situation where we cannot avoid third-party packages altogether. So third-party packages can be something like even MLflow, all the workflow orchestrators are third-party packages that I've showed, and all the Elastic components, they're third-party packages. Kubernetes, these are third-party packages that you can basically cannot live without of in today's world. But moving on ahead, you'd want to minimize as much as possible. Suppose if you're utilizing a package from scikit-learn, I would advise to know what algorithm you're using because it gives you an ease when you're doing your POC for multiple models, comparing all at once. But once you know which model is good for you, it would be wiser for you to code it yourself so that you can avoid the compliance checks. Because once you go through the security compliance checks, you would have to monitor the vulnerability for each of those packages and each of the transitive dependency as well. So in a recent project that we did, we had over 3,000, over 1,000 transitive dependency package, but we only used a very few because the transitive dependency, that is, this package scikit-learn is dependent on certain other packages, and those packages depend on even more packages. So it'll bloat up so big, and you'd want to avoid that as much as you can. Then access control. So access control is when you'd have to define all actors of your system. So for i.e. roles, not just customer, seller, and admin, but also O&M, operations and maintenance user. So these are the users that you would see in the last stage of the use case flow, and they would oversee the entire process, but you should always keep in mind what access they have. They do not have admin access. They would have access to only certain monitoring elements that they should keep in mind. Then logging. Now, security logging is something that you'd have to do for compliance, but please log both security and general events. It'll save you a lot of time in the future, because if you have something wrong happening in the system, you would not know what happens when you have over hundreds of components working with each other, unless you make sure you log the right time, log every event. Then traffic and data protection. The product that you deploy in production would have to interoperate with multiple other products too. And you would have to make sure that not only you encroach on other data, but also make sure that the data that you supply between your components are protected. So you would have to use transport layer security and also protect your data in certain sort of encryption as well. OWASP top 10. This is something that every security engineer will be aware of. It stands for Open Web Application Security Project. And they have listed the top 10 critical security risks to web applications. So when you're deploying any application that you can interface through the web, you would have to keep this in mind. Finally, the right to privacy. So this item took by storm when certain organizations came into trouble because of GDPR, that is General Data Protection Regulation. This will differ from certain region to another, because GDPR is mostly Europe-centric as far as I remember. But other regions too, depending on where you want to market a certain product, you'd have to think about privacy, but always keep the customer right to privacy in mind. So privacy is not like you're taking any private data. Even a username and the storage of the password or the encryption of the password can be considered a person's right to privacy. So the entire set of users who are in the system need not to know what are the other users who are there in the same system. So you can't have a simple list of items to select the username or knowing even how many users exist in the system. So this also comes under the right to privacy. And coming back into the 3PP packages, one vulnerability that hit us by storm days back, I think just last month, it took form, Log4j. Everyone in the software community would have definitely heard about it, and it has become a huge vulnerability that they had to tackle, because this is a logging package that is there in many components, even Apache Spark and Elasticsearch and Logstash, and they would have to mitigate it. And this would mean that anybody who has access to the system, just the monitoring system, can use it as a vulnerability to hack into the entire system, sort of like a rootkit. And this is just a simple example of what it means to limit the 3PP package. If you are able to, but certain things cannot be avoided, you'd have to go for the mitigation steps. But the lesser movable parts for a system, then the more control that you have over it and the more secure it can be. Now we move into the issues and challenges. So it can be of two forms, technical and non-technical. So starting with technical issues, you're not exactly building a model that can solve any problem of a certain kind. You're building a model to solve a certain use case. So make sure that it's specific to that use case. So suppose I'll come back to anomaly detection as an example. I'm writing a model to solve an anomaly with a given KPI. So I have a time series data and I need to identify anomalies in it. Now, I don't need to provide the world-class anomaly detection algorithm that is published a few weeks ago to implement this. A simple Z-score model can do the trick and satisfy the customer criteria. One, because it's interpretable, and two, it works. It works for the given use case, and it is robust and is also easier to debug. And the subject matter experts also understand it. So I don't need to go for more complicated deep learning methods or much more complicated items to even reduce computational complexity to solve this problem. Remember, you're writing a code to solve the problem. So keep it as simple as possible. Then stability of the environment and system. This comes to the basics of developing any software. Things will fail, and you should expect things to fail. When you're testing a certain product in the test environment and the production environment, we had different types of failures in each of those environments. Some can be reproduced, some cannot even be reproduced, because when you're working in an industry, you would not be working with bare metal systems. So bare metal systems are systems that you can connect to a physical, let's say a physical computer that you can connect over the internet. These are systems that run on mainframe virtual machines. And every node that you have access to are virtualized nodes. So since it's a virtualization we're talking about here, systems may not be as stable as it can be. If something wrong happens in the virtualization, the entire software can be affected. I mean, the entire machine that you're connected to, entire set of machines can be affected. If something wrong happens to the data center, every machine that is connected to the data center can be affected. And there are many, many more items into this, but so you should keep into account stability of the environment system. And this is where, again, logging comes into play. The more logging that you have, then the more you would be more informed about if anything wrong happens in your solution. Then you should avoid the one user to rule it all problem. So whenever anybody starts designing a solution, when they first deployed, even in a first office application, they would use an admin user. That admin user would be able to use all functionality of the system, and maybe an end user, but even for all testing, they use only an admin user. Is best to avoid this altogether. So you should start thinking about the users that are going to use the system. I would say even before the POC phase, and even at the start of making the first office application, design all the users that are going to be using the system, that are going to be using the system, so that the people in the maintenance team has no access to the data of the actual users, and the administrators would be completely different from the production team, etc., so that you know which role corresponds to which actor. Time sync across all your nodes. This would be fairly straightforward. You would think that, why is this a problem? Now, I'll give an example what happened to us. We deployed a solution which had over 50 nodes, and we thought, okay, then our customer partner was the one who provided the nodes to us. So the solution we tested, we regularly tested in the staging environment, and that is a development environment, and it worked pretty well. It should also work here. And we found out that certain data that were coming because of the logging is coming 10 minutes earlier to the time it was generated. So it was if it was generated now, then we would have received that particular log file 10 minutes ago. It didn't make sense. So we started looking into the data file. We thought something's wrong with the customer environment. Maybe right from the source file, maybe the source file timeline was off, and we checked it. They said that we've all checked, everything is an NTP sync, network time protocol. Then when we looked at the nodes that are provided to us, each node was in a different time. And this can happen when you randomly install a node. Although it should be an NTP, it may not be. So you would have to make sure that your time is synchronized across all of your nodes and confirm that even before the installation. staging and production environment. Staging is an environment that you would have to test your application that is closest to the production environment. You test your application in the development, after you test in development, you test in your staging environment, then you start testing in the production environment. Make sure that the staging and the production environment is as close as possible. So if there's a limitation in your production environment, make sure you reflect that limitation in your staging environment as well. And high availability and disaster recovery. Now, this comes into the aspect of vertical scaling. High availability is when you have your system working even at a reduced capacity if a failure happens. So when I have a Logstash node, Logstash is a data pipeline that can fill the data the raw data that is sent by Beats, right, and send it to Elasticsearch. That is your database. And if I have a single Logstash running in here, if that fails, then every data that is being produced will not be sent to the database. So that is why you need to have more than one. So you can have 2, 3, or even up to 4. So if any one fails, it'll automatically refer to the other one so that the data can be sent in that pipeline. So the pipeline would not be destroyed. So if there's any problem with so all of these single link failures can be avoided. This is high availability. Disaster recovery is, suppose that the entire data center goes down. You want to make sure that you can recover the data from it. Of course, your system would be off for the entire duration of the disaster. But once the system comes back online, you would want to make sure that your entire product is not adversely affected. So it should come back on by itself and provide the necessary backups so that you can continue your business function. That is disaster recovery. Non-technical issues. So first would be SME availability, so subject matter expertise. In any data science problem, it's all about applying machine learning to a certain data that you may most probably not familiar with. So even if you're within computer science itself, there are many other items that you will not be familiar with. All you know is how do you manipulate data and apply machine learning or any other type of statistical method for you to solve a problem. You would have to work with a certain subject matter expertise like a network operator or a maintenance engineer or a radio expert or RAN expert to know how your output makes sense. And you should make sure that those members are available before you start the project so that they can evaluate your outputs. So if I'm finding that certain KPI, let's say handover failure rate with respect to downlink rate and uplink rate is anomalous, I can say it's anomalous because it's statistically so, but there has to be a subject matter expertise saying that it is anomalous and this anomaly is useful for us so that you can tune it accordingly, or to which degree it is anomalous. How do you assign a severity to a certain anomaly? So you would have to confirm whether your SME is available for you to design a product, because in the end, you design a product to be used by people. And if it's not useful for those people, it's kind of not useful at all. Then data-centric constraints. This is similar to what I said regarding the failure of systems. And certain times your data center could be overused by another application because this is the mainframe we're talking about, and network and other resources are shared to a certain degree. So if your customer network is highly utilized, even you will not be able to transfer data between your own nodes. We should keep these other items in mind. And apart from that, there are also resource constraints. You are developing a solution that can run in a certain production environment, and you should ensure that that environment has sufficient resources for you to run your application. If the environment does not have sufficient resources, so you don't have this compute nodes and you don't have this much RAM space available, then you would have to either redesign or look for another customer or look for another solution, or you're going to have to negotiate in such a way that it works well for both of you. Then carefully set clear expectations. This goes to any project, be it machine learning or not, or AI, or even regular software project. When you start with a certain expectation that you're going to do a task, so let's just say I'm going to build a product to forecast revenues or building a product to forecast a certain KPI so that I can identify anomalies. This is the problem statement. And this can go to any level of complexity. So you would have to focus on breaking down your problem as much as possible, even before you start the project, and identify what is your common language between you and your requester. So a release for your team could be different for a release for other team. So when you say I'm going to provide my first release here, you would think I'm going to provide my first installment for this particular component, so that these components would be ready for the application. But from a customer or requester perspective, a release would be a fully functional system. So understand for each of your phases of your project that the communication between you and your requesters and your customers are very clear, and what you mean is also very clear, and what they mean is also very clear in a common understanding. Then that does not mean that you come with a certain sort of requirements and you stick with those requirements for the rest of the projects. Requirements would constantly evolve. When you start with a certain requirement at a start of a project, that was with your available knowledge, and your meaning the available knowledge of entire team and your customers at that instance of time. Everyone is learning and constantly. So as the project progresses for several months, you would understand that those requirements you set earlier may not have certain value right now, or you'd have certain other requirements that gives even more value than the ones that you've already set. So requirements do evolve, but make sure you keep it in a common barrier. So whenever it evolves, make sure you change your timelines too. So that comes back to what I just said. Now make periodic revisions to the plan, and be very wary of IP and licenses. IP in sense of intellectual property. And this, in fact, you'd consider certain institutions to be patent sharks, so that all they do is patenting, and they gain the input based on finding the infringement of other products. For instance, you would have, I think everyone who knows about deep learning would be aware of dropout. So dropout is a certain a functionality that you can add to avoid overfitting by removing certain nodes of a neural network. And dropout functionality is actually patented by Google, which means you can't legally consider in your solution, if you implement dropout, you can sell it. That means Google can write a case off on you for IP infringement. So whenever you're implementing anything or any package, clearly identify what is the license used for it. And one of the license would be GNU GPL version 3. So this particular license is considered more of a virus type of license. So if you're using any package that has a GPL v3 license in your product and shipping it, that means anybody can ask you for the code. Basically, your code also becomes open source. So this is the type of virus like licensing. So these sort of open source products can be used when you're doing POC without too much problems. But when you're productionizing it, making it into a marketable product, be very wary of what licensing. I think Apache v2, that can be a better license, more of a softer license. It's not like a virus license like GPL v3, but all these items should be put in mind. So you can't mindlessly create a product and expect to be sold without coming back at you unless you take a look into these license specifications. This is very important part. Yes, now we can review the concept that we just went through. So use case flow consists of these 5 stages: problem identification, proof of concepts, first office application, production and maintenance. And model performance across 3 dimensions. We have evaluation metrics, complexity, interpretability. And an environment, you should keep in mind the resources in terms of compute and storage, and also the network connectivity. And in pipelines, we looked at both machine learning pipeline and the data pipeline. And we've also looked at a certain aspects of security and reliability. And if there is 3 things I'd like to keep in mind out of the few that I mentioned, it would be security by design, and limitations on third-party packages, and keeping privacy in mind as well. And in issues and challenges, we've just looked at both technical and non-technical challenges. So with that, I can open the floor to some questions. Thank you.
That was such a powerful session, sir. With lot many insights, like really at the production level. If we students are trying to work on some project on AI and or similar things, these things will definitely come handy to us. And this was amazing session. Very knowledgeable. So, guys, if you have any queries, any questions, please feel free to interact with sir or feel free to put it in the chat box. And our team will also be navigating through the YouTube live chat box if there are any questions. Thank you once again, sir, for coming, and what an amazing session.
Thank you,
Sir.
Zahash.
And then really amazing the presentation as well.
Thank you.
Honestly. So
There are some questions. Achha. The audience is thank you, conveying their regards to you, sir. So please
yeah,
accept
there are
that.
multiple thank yous in my DM, direct messages.
Exactly.
That thank you for this informative session. Thank you, sir, and also this was amazing interacting with you, sir.
So
So
there's a question from the audience. What do you think we should identify a problem because it's itself a task? So what's your suggestion or take on that?
I think identification of the problem starts with this, again, well-known quote, necessity is the mother of invention. So whenever you see that there's something that makes you feel uncomfortable, I would say it can be one or more of three things. So either you do not understand that whatever you are looking at, so a certain part of a system makes me feel uncomfortable. That means either I don't understand the system well enough, or I don't understand the processes involved in the system well enough, or the processes are not defined well enough. So they're definitely one or more of these items. So once you think that there's a problem somewhere, so you are facing certain difficulties. For instance, anomaly detection is not something that I was comfortable with. It was completely new when I got into this. When I got into Ericsson, and that is something that is given to me. And again, when I started feeling uncomfortable about it, I started learning more about it. So you'd have much more clarity in where you want to solve. So start with something that you're uncomfortable with. Then things open up. Certain things would make sense, certain things would not make sense. So there's something that does not make sense. So there you have an opportunity. So make sense of things that does not make sense. So that's when we talk about more of these algorithms. And I saw many publications coming from deep learning identifying anomalies. And then I thought, does it make sense? No, it doesn't. If I give that solution to the customer, would it be useful for them? It's not. Then how is it useful to anybody, right? They have a labeled data set, but labeled data set is not something that you can see in reality. Label something that you would have to generate yourself. It is there in certain university repositories, but when you come to production, you can't find labels. You need people to evaluate them. So that is why I devised three methods. One is the method of anomaly detection itself, then a method of intuitive anomaly decomposition, seasonality decomposition, and a method where any normal person can view an anomaly detection system that can group all related anomalies together and view them for a case-by-case basis and say how many times each of these anomalies occurred in your system. And I've applied pattern for all three of them the same. So again, find what is something that you're most uncomfortable with and go in that direction, and that should help you.
that was such an amazing advice, sir. I could see one more question in my DM, and they were asking, so why do you opt for this research-oriented career?
Yeah,
So what ignited you? Yeah.
Yeah, that's a nice question. Research is something that I've always found passionate about. So I'm a person who likes to ask questions. And those things that was very welcome by certain teachers and may not be welcome by some others. And when I find out that there's certain questions that even teachers cannot answer, that's when I had to search for the answers to things that I need to know. And it became more of a habit, and from a habit to an obsession, to a passion, and that is what I went towards.
Thank you so
Wow,
much, sir.
that
was
is
really
inspiring.
a
Yes.
insightful journey.
Thank you.
Right? Yeah. So we'll move forward, and thank you, sir, for planting a seed for thought among the audience and between us collaborators and the organizers. Really, thank you. So moving forward, I just have a quick announcement for the attendees. So dear attendees, CheckIt brings to you its mega internship program from where you can gain insight into the real world. And for more information, you can please head out to our website, and kindly note to fill the feedback form shared and circulated at the end of the session so that your presence in the consortium can be marked. Over to you, Sir Harsh.
Okay, thank you.
So now it's time for vote of thanks to our esteemed speaker for today. And thank you very much, sir, Mr. Dr. Ebenezer Isaac. Such a lovely presentation, amazing knowledge. Like I was thinking there is so much to learn, and where are we who are learning AI and ML or starting with it, and then how a professional way to handle any project, what are the criteria to be considered. I definitely learned now, and definitely we will involve all these processes in our independent projects as well, sir, what we are currently working on to. So this will be definitely very helpful. Once again, thank you very much, sir, for accepting our invitation, being our speaker, taking out time from your busy schedule on Monday. that is also commendable. And thank you very much. So I will request my team to kindly share their screen and present a token of gratitude and a memento to our esteemed speaker, Dr. Ebenezer. So, sir, kindly accept this token of gratitude, heartfelt thank you note to you. And yeah, thank you very much, sir, for accepting our invitation. Thank you, sir. Now, without thanking to the another two people, Dr. Rajeshwari Hegde and Susan ma'am, we cannot move forward because without their mentorship, without their guidance, and without their support, we may not be able to achieve this success, and we may not be able to come this far. So thank you, Dr. Rajeshwari and Dr. Susan. It means a lot. I would love to thank our sponsors for the event, Verivo Motors and EduCheck, for believing in us, and each and every collaborators who are helping us in each some or other way to making this particular international consortium a grand success. So thank you very much, guys, and thank you very much to each and every attendee. So thank you. So thank you very much, and it was amazing time to interact with you, sir. So
yep, and all the best in your future endeavors too.
Thank you.
Okay, bye.
Bye, sir.
Bye. Take care. Now,
day one was really powerful and informative.
Guys, will be a relaxation. Yes, it was. Definitely, it was. Yeah, yes. I'm audible.
Your network is glitching. Yeah, is it just for me or for everyone?
Can you hear me now? Can you hear me now?
Could you just switch off your camera? Maybe then you know.
For sure. I did that. Is it better?
Yeah, for sure.
Great. So Achyut, can you quickly stop this particular live